Hi everyone, my name is Madhukar Shinde. I am currently doing second year in MIT OE Civil Engineering. My roll number is 125. So today I am going to discuss a topic from geotechnical subject, that is seepage and seepage pressure. So the topics which I am going to cover is what is seepage, second is seepage pressure, and then seepage force. So first of all, before going into the details, let's understand what is permeability. First of all, let's consider a soil mass. So if you maximize this, then you can find these particles which are known as grains. So these grains arrange themselves in such a manner that they have these gaps between them, which are also known as voids. And these voids interconnects and form a highly complex network of irregular tubes like structure. If water is going to flow, they will flow like this. They'll find a way somehow. So these are two types of soil grains. First is it is very irregular and very narrow. So this will provide very resistance to the water which will going to flow through this way. Second, it is very regular and open, which will the water will easily flow through it. So now what is permeability? The property of soil which permit a liquid to flow through its void. Now it is important, through its void and permits a liquid. This is the permeability. So now let's take an example. Let's consider it soil grains. The water will flow like this, in this way. So when the water flows, we can say it in two forms. Either is a seepage, when soil structure is damaged by water, you can see, and second is a surface flow, when soil structure is not damaged. Now when soil mechanics is concerned, we talk about seepage, and in hydraulics we talk about surface flow. So this is the seepage. Now water is flowing through one end to another end, so there must be some pressure, right? And that pressure is known as seepage pressure. Now when the water flows, it must have some kinetic energy into it. That's why it's flowing. If I take an example of a ball, it flows, and we know that the kinetic energy is half mv square, something like that. In the same way, water also has kinetic energy, that's why it flows. And Bernoulli sir said that when water flows, it must have some pressure energy, velocity energy, and some datum head it has. Since the water flows gradually, so we can neglect the velocity energy, so we left with pressure energy and datum head. So that gives us pressure head plus datum head is equal to pH, that is piezometric head. So let's understand what is datum head is. Let's see this diagram. Here we can see that there are two holes in this is soil, and this level is of water. So this height, you can call this level as datum, and this height is HA, and this height is HB. So you can say that this is higher level than this, so water will flow in this direction. In the same way, when water is flowing through in one side to another side, there must be some head difference. That's why it's flowing like this we have seen. So this is the head loss also called, and is denoted by delta H. So we can write as delta H is equal to HA minus HB. Okay, this is the delta H, and these both are the piezometric heads. This head is called piezometric heads. Now again, when the water flows, it flows with some pressure. So we can equate the pressure as we know from hydraulic equation. Pressure is equal to rho GH. This is the density G and the H, height. Now here rho will be of water, G is the constant, and H will take this head loss. So we can write rho W and G as gamma W, which is a unit weight of water, and this pressure which is applying here, this is the seepage pressure which we are talking about. So we see that seepage pressure is equal to gamma W into delta H. Delta H we know from here. Now there is one more term comes here, which is hydraulic gradient, which is represented by I and is equal to delta H upon L, where delta H is the head difference we have seen already, and L, it is the thickness of layer. So we can rearrange and write it as delta H is equal to IL, head difference, is equal to hydraulic gradient into thickness of layer. So moving forward, we can write seepage pressure as this gamma of water into delta H that we already derived, and here we can replace delta H by IL, we have seen, and in some books you can see L as Z. So at last seepage pressure becomes gamma W into I into L. Now the last topic, last part is seepage force. Since we know that force is equal to pressure by into area, before it is force is equal to pressure is equal to force upon area, so that becomes like force is equal to pressure into area. So we can apply the same thing here. Seepage force is equal to seepage pressure into area. Seepage pressure we know already from here, gamma W into I into L into area. A is the area. So length into area, you know, for anything, suppose this is a tube, this is the area L, A, and this is the length. So area into L, this becomes the volume of this whole tube. So we can replace this both as the V. So this becomes gamma W into I into V. This is the force. So if we take V to this side, this becomes seepage force upon volume. We can say it as seepage force per unit volume. It becomes gamma W into I, where gamma W is the unit weight of water and I is the hydraulic gradient. So till now we have covered seepage, what is seepage, under it we have also seen permeability, and then seepage pressure, and after that seepage force, and we have also derived seepage force per unit volume, which is gamma W into I. So Thank you.